Hey there, Geometry Cats. Welcome to Chapter 2. We're one down. 11 to go. Alright, today we're going to talk about patterns and inductive reasoning. What is inductive reasoning? Good question. Inductive reasoning is the reasoning behind patterns you observe. You see a pattern and you induce what the next one will be based on the previous ones. You do this all the time. You just don't call it inductive reasoning. Alright? Even like if you're playing a sport and the guy you're facing has a tendency to always go right in basketball, you're going to induce that the next play he's going to go right. That's induction. Alright? So let's do some of these. What are the next two patterns in the sequence? I'm also going to warn you guys this. There's only so much I can do for you with patterns. You guys just have to get used to seeing them and drawing conclusions. Alright, going from 40, 45 to 40, 40 to 35, 35 to 30. Alright. What's the change that's happening each time? I'm either multiplying it, dividing it, adding, or subtracting. Well, it looks like I'm subtracting 5 each time. So what's 30 minus 5? Well, 25. It's 25 minus 5. 20. That was easy. That was like Mickey Mouse Clubhouse stuff. And I know, I watch a lot of Mickey Mouse Clubhouse. I have little kids. Okay. Next one. We have a rectangle, a rhombus, rectangle, rhombus, square, rectangle. So my next one, what do you guys think? It looks like I'm just drawing. Oh, jeez. Oh, no. Alright, this is so bad. What do you think I'm doing? Well, I'm connecting these midpoints is what it looks like. So my next one's going to be like a diamond. I have to draw that again. Hey. Again, we just take our midpoints of each of those and connect it. If you don't see it, I'm sorry. All right. Now, if you want to find the 10th term or 100th term, you have to make a conjecture. A conjecture is a conclusion you've drawn. Like every third play, this guy goes to the right. Every time they line up in an I formation, they run through the A gap. You know, stuff like that. Those are conjectures. Okay. Every first day of school, we have hot dogs for lunch. That's conjecture because I've been around for like 7 years first day of school, and so it's hot dogs. All right. So let's make a conjecture about the 21st term. Red, white, blue, red, white. I don't even know if they're colors. Red, white, blue. America. Okay. Red, white, blue, red. I'm going to assume that goes on forever. Now I could just go through and write out 21 terms. Who wants to do that? Red's my first, second, and third term, right? I'm going to teach you the ACT way to do this. So on my first, second, third term, I can take 21 and divide it by 3, right? There's 3 things in my pattern and 21 total terms we're looking for. Well, that's 7 with remainder 0. So if you get remainder 0, 3 divided by 3 has a remainder 0. My 21st term is blue. B. Whatever floats your boat. Now what if I want to find the 91st term? Well, I could do 3 divided by 91, which is 30. Remainder 1. Remainder 1, well, that'd be R, because R is 1. 1, 2, remainder 0. We'll do some more of these. You could just write it out if you want to. Say every third term in 3, 6, 9. Stinks up. All right. Next one. Not all conjectures are true. For example, I could say we always have hot dogs first day of school, and then one year we have grilled chicken, and then my conjecture would be disproven. That's a counterexample. A counterexample is the easiest way to disprove a conjecture. All right? So let's go through some counterexamples. Number 5, A. If a flower is red, then it is a rose. What's a red flower that's not a rose? Where's my wife at? Do you guys know what snapdragons are? Snapdragons are a red flower that are not a rose. That's a counterexample. Okay. B. One and only one plane passes through any 3 points. Now this one you might say, well, that's true. But what if all those points are on one line? And 2 planes can pass through a line. In fact, infinite can. So your counterexample would be if, oh dear. I might show you that in class. Your counterexample would be if 3 points lie on the same line, at least 2 planes pass through them. Okay? So if all those points are on the same line, because 2 planes make a line, so you know at least 2. C. When you multiply a number by 3, the product is divisible by 6. Here's your counterexample. What's 1 times 3? 3. 3 is not evenly divisible by 6. Alright? So 1 is a counterexample. Because 1 times 3 is 3, and 3 does not evenly divide into 6. Alright? That's all I got for you guys today. Think of some more counterexamples for conjectures. I don't know. Have a good day. Enjoy.